Welcome to Unit 5 of SAT Math, Passport to Advanced Math, Part 2. We're going to start off with solving quadratic equations. So quadratic equations look something like this, and any solution for the value x basically gives this equation an answer of 0. So usually you want to try and look for this 0. Okay, question 1. What are the solutions to the equation above? Here we see that we already have it in factored form, so that this t plus 1/3 times this t plus 2/3 must be equal to 0. So for this to happen, either t plus 1/3 equals 0 or t plus 2/3 equals 0. And in solving these, we get t is either equal to -1/3 or -2/3. So we can go ahead and pick answer choice A. 2. If s and t are solutions to the equation above, what is the value of -s minus t? So here, similar idea. Our two scenarios that we have are 2x minus 3 equals 0 or x plus 4 equals 0. So over here, if we add 3 to both sides and divide by 2, we see our x is equal to 3/2. Here on the other side, for x plus 4 equals 0, we see that this just means that x is equal to -4. So in this case, this is our s and our t. So the s and t can basically be evaluated as -3/2 minus -4, which is going to give us a value of 2.5, positive 2.5. Question 3. How many unique real solutions does the equation above have? So very similar to the above, we see that we already have them in two factor forms here. Again, we see that our value of z will be 5/3 and -5/3, and those are two distinct solutions. One's positive, one's negative, so they are distinct. And of course, since we see both of those are there and it's quadratic, that's as many as we can have. So 2 is going to be the number of unique solutions, unique real solutions. Okay, so now let's move on to factoring. There's 3 different ways we can solve in a quadratic equation: factoring, completing the square, or the quadratic formula. First, we're going to start with factoring. Basically, we set the equation to 0, and then you just factor the equation, and then set each factor to 0 so that you can solve for what that 0 or that answer is. Okay, question 4. What are the solutions to the equation above? We have -64 x squared is equal to -13. So the factoring here itself isn't super complicated, but let's go ahead and break it down. First thing we want to do to isolate the x, we want to go ahead and divide both sides by -64. This leaves us with just x squared on the left, and because the negatives cancel, just 13/64 on the right. So now what we want to go ahead and do is we want to take the square root of both sides so that we're just left with x on the left. This means we have x equals square root of 13/64. However, because we took the square root, this is plus or minus square root of 13/64. Then we can also simplify the 64 in the denominator because it's 8 squared, but the 13 is just going to have to remain in the radical. So we're left with plus minus radical 13/8, which gives us answer choice C. Okay, question 5. Given that a is greater than 0, what is one possible solution to the equation above? This equation at first looks a bit complicated because there's so many a's here and there's such big powers. Let's break it down and try and isolate the a's on the left so that we're just left with 0 on the right. So we have a cubed times a squared minus 10 plus 9a equals 0. Now let's go ahead and distribute and simplify a little bit. We have a to the 5th minus 10a cubed plus 9a equals 0. Now we can factor an a out. So we're left with a times a to the 4th minus 10a squared plus 9 equals 0. So now this looks a little bit more familiar, but we still see a to the 4th and a squared, which we're not as familiar with. We can employ a little bit of a trick here. What we're going to do is at this point, we're going to substitute in a value of b. And this b is just going to be equal to a squared. So since it's just equal to a squared, we can go ahead and rewrite this section right here in the parentheses. We're going to leave this out here alone for now, but we'll come back to it at the end. So rewriting this, we get b squared minus 10b plus 9 equals 0. This is something we can factor. This we know we can factor into b minus 9 times b minus 1 equals 0, which is great. This also tells us that b equals 9 or 1. And since we know that b is just a squared, we know that a squared is equal to 9 or 1. So a is equal to plus minus 3 and plus minus 1. So those are our values of a there. Don't forget this value of a here, which suggests that a can be equal to 0, which means that our possible solutions are a equals -1, -3, 1, 3, and 0. However, since we know that a is greater than 0, our possible solutions are a equals 1 and 3. Okay, now let's look at difference of two squares. So we have a squared minus b squared is going to be equal to a minus b times a plus b. And this is a good rule to employ for a lot of factoring purposes. So looking at question 6, we're looking for the solutions for this equation. Let's go ahead and try and set this up into something of the form a squared minus b squared. So what we're going to do is we're going to subtract 36 from both sides. So we get 0 equals 4a squared minus 36. In this case, we know that 2a squared is equal to 4a squared. And we know that 6 squared is equal to 36, which allows us to do difference of squares to say that 0 is equal to 2a minus 6 times 2a plus 6. Oops. 2a plus 6. So now what this allows us to do is to set these equal to 0. So 2a minus 6 is equal to 0, and 2a plus 6 is equal to 0, which means if we do a little bit of rearranging here, we get a is equal to 3, and a is equal to -3. So answer choice B. So similarly to this, we have perfect squared trinomials. So also something good to know that we have x plus k squared is going to give us x plus 2kx plus k squared. Similarly with x minus k squared, we get x squared minus 2kx plus k squared. While these are great to know and are pretty self-explanatory, you can always just write out the squares and distribute out using FOIL. So looking at question 7, we see that we have the equation x squared plus 2y plus y squared equals 1. And we're asking which of the following correctly expresses x in terms of y. So first thing we want to do, we want to use our perfect squared trinomials to simplify this to the form x plus y squared is equal to 1. Now what we can do is we can take the square root of both sides so that we get x plus y is equal to plus minus 1, positive or negative here. And since we're looking for x in terms of y, let's just go ahead and subtract y from both sides. We have x is equal to negative y plus minus 1. So that's going to leave us with c as one possibility. Of course, we could also have x equals negative y minus 1, but that's not an answer choice here. Okay, quadratic formula. Quadratic formula is one to know, and it looks complicated, but in time, if you use it more and more, you'll remember it. So quadratic formula is x is equal to negative b plus minus square root of b squared minus 4ac all over 2a. And this is based on the fact that you have some sort of equation of the form ax squared plus bx plus c is equal to 0. So this is our a, b, and c that they're referencing in the equation. So question 8 says, what are the roots of the equation 3x squared plus 12x plus 6 equals 0? So as you can see here, we have our a, our b, and our c as I wrote above. So let's just go ahead and plug this into the quadratic formula, and we see that we have x is equal to negative b, so negative 12, plus minus the square root of 12 squared minus 4 times a, which is 3, times c, which is 6, all over 2 times a, which is 3. So of course, this means that because we have the plus minus there, there's going to be two possible answers for this one. One where it's negative 12 plus that, and one where it's negative 12 minus that. So of course, we're going to get two answers here. So they left the plus minus in the answers for this problem, which means that we can simplify this out and see that our answer is going to be a, negative 2 plus minus radical 2. Okay, a is the product of the x coefficients, and the sum of the solutions is negative b over a, and the product of the solutions is c over a. So this is something that you can also work out for yourself if you would like, based on any sort of equation and just seeing how the roots play out once you FOIL the equation out. But again, remember, we have ax squared plus bx plus c is equal to 0. The sum of your solutions to x for this equation is negative b over a, and the sum of your products, so the product of your solutions is going to be c over a. So looking at question 9, we see what is the sum of all the values m that satisfy 4m squared minus 8m plus 4 equals 0. So for this here, we can see that the sum of all values m, the sum, that's what we have right here, which is negative b over a. So this is our b, which in this case is negative 8. So make sure we remember that negative, and this is a. So negative b over a is going to be equal to negative 8 over 4. So that's just going to be positive 8 over 4, or 2. D is our answer. Okay, Question 10, given the equation above and that I plus j equals 16, what are the two values for k? So here we see that our k unknown is over here, and then we have some sort of factored form of the equation here. Right now it looks like there's three unknowns in one equation. However, given this information, we'll quickly see how this plays out. So let's go ahead and FOIL out this expression on the left here. So we have ix times jx, so it's ijx squared plus 4ix plus 3jx plus 12 is equal to 39x squared plus kx plus 12. So now looking at this, we see that terms have to line up. So the 12 has to line up with the 12 because neither of them have any x in them. This term has to line up with the kx because they're the only terms on the left and the right that have just x to the first power. And of course, this has to line up with this because they're x squared terms. So just mark those out. The x squared terms have to line up, and then we see that the x terms have to line up. And then of course we see that the constant terms also have to line up. So what this means is we can say that ij is equal to 39, and that 4i plus 3j is equal to k. So now what we can tell from this is that if ij is equal to 39, that means that we find a value of I is equal to 13 and j is equal to 3, or vice versa, which means we can finally plug this into here in this equation we have here so that we solve for two possible values of 61 and 47, depending on which I and which j you pick. Okay, quadratics expressed as square roots. So, question 11, what is the least value of p that is a solution to the equation above? So here we have 4p to the 1/2 power plus 5p equals 0. What is this also? 4 square root p plus 5p equals 0. So similar to a trick that we used above, let's write this as x is equal to square root p. So now our equation becomes 4x plus 5x squared equals 0, which is a little bit easier to solve. So what we want to do is we want to factor out an x. So we have 4 plus 5x equals 0. And now setting our solutions to 0, we have x equals 0 and 4 plus 5x equals 0, which leaves us with an answer of negative 4/5. B as our answer choice. Okay, now let's look at question 12. Find out values of x that satisfy the equation. So looking at this, we see that we have a radical on the left, but it's not alone. So it'll make it difficult to get rid of the radical. So let's go ahead and isolate it by adding 4 to both sides. Now that means we're going to have square root of 10 plus 3x is equal to x plus 4. We can go ahead and square both sides to now get rid of the radical. So we're left with 10 plus 3x is equal to x plus 4 squared, which is the same thing as x squared plus 8x plus 16. Now, to set it equal to 0 and ended up factoring for x, we're going to go ahead and subtract 10 minus 3x on both sides so that we get left with 0 is equal to x squared plus 8x plus 16 minus 10 minus 3x, which allows us to simplify this to x squared plus 5x plus 6, which we can then factor to x plus 3 times x plus 2. So we know our answers are going to be x equals negative 2 and negative 3. Answer choice C. Okay, so now we're going to interpret nonlinear expressions. So constant terms represent, in natural conditions, coefficients of variables represent incremental change. Very similar to what we talked about before, but we'll see that this kind of plays in differently here. So pay attention to exponents and PEMDAS as well. Of course, that's the kind of main change that we're looking at. So question 13, a textile company produces quilts. The function above gives the cost C of Q in dollars, producing Q quilts. How many dollars is the fixed cost of production before any quilts are produced? So remember, fixed cost or constant terms or initial conditions are the constant terms. So in this case, what is our constant term? This term has Q in it, this term has Q in it, but this does not. So it is our initial condition or our constant term. So what is the cost of production before any quilts are produced? It's going to be $2,000. Okay, question 14. The amount in an investing account I of t after t years is given by the function above. How much money was invested into the account at the start? So again, our initial condition. This one's a little trickier though, because we just really have this one term here, right? However, let's look closely. Our variable, or t here, is in the exponent up here, which means that as t grows, the whole thing is going to change. But it's scaling up by the factor of 1.03. So that's kind of like our incremental change. Whereas if t equals 0, so at the start, what's going to be the value that we're left with? It's going to be this constant value here. So 3,000 is going to be our initial money invested into the account. So t equals 0 year. Okay, now let's look at question 15. A clothing store calculates its monthly revenue, R of P, in dollars is given by the function above, where P is the number of garments sold each month. What is the maximum value of R of P? So let's look at this equation here. At first, again, we're not quite sure where to start with the maximum value, right? Nothing quite jumps out at us. However, let's break this down. We have this term here, P minus 260, that gets squared, which means that this whole term here will always be positive. If this is always positive, multiplying it by negative 0.31 means that this whole term will always be negative. So that means as P increases, the only changes that can be made are negative changes, which means 9,500 is going to be, you're going to subtract something from 9,500, whatever that might be, depending on what P is, which means 9,500 is actually going to be our initial condition, but also our maximum value in this case. So it looks like our initial condition, but in this case, it's our maximum value. Because you can think, if you think of this as a parabola, the parabola is going to have a negative 8 term because of this right here, which means the parabola facing down, our maximum value is going to be this 9,500 right at the start. Okay. Looking at systems of linear equations, word problems. Question 16 says, a German basketball team sells tickets at a current price of $25 and an average of 4,000 seats are bought. The analysts predict that for each $1 increase in ticket price, 100 fewer tickets will be sold. Which equation represents the amount of money that the basketball team will earn from ticket sales? Y, based on an X dollar increase in ticket price. So, what do we have here? A couple of different information, but we have X and Y that basically is our equation, as we can see from these answer choices. So, what we're going to do is we're going to set Y is equal to the cost per ticket times the number of tickets sold. And this will give us our ticket sales Y. So what is our cost per ticket? Our cost per ticket is this $25 that's currently there, but we're basing it off an X dollar increase. So our cost is actually going to be 25 plus X. So now, what is the number of tickets that we're selling? The number of tickets is selling is that 4,000 originally at that $25 price. However, because we're seeing every dollar increase in ticket price, 100 fewer tickets, the number of tickets we sold will be 4,000 originally, but for every dollar increase, and X is our number of dollars increase, we're going to lose 100. So we're going to be subtracting 100 times X. So in this case, this is going to be our equation for Y, which we see lines up perfectly with answer choice A. Okay, 17. Over summer break, James earned $250 from his job. He decides to put the money in an investment account that yields 10% compounded annually. If James does not make any deposits or withdrawals from the account, how many years will it take him to have at least $300 in his account? So, the amount we're going to change is going to be a 10% interest compounded annually with $300 as the goal and $200 at the start. So what happens here is we're going to have $300 as the goal, $200 at the start. It's our initial condition, remember from that other problem. And if it's compounding 10% interest, that's 1.1 times here. And of course, we're going to multiply it by the number of years. We'll call that T. So we're basically looking for T here. So if we do a little bit of calculation, we can see that, you can try and plug it into your calculator, or we can just test some values to see how this works out. So for example, if T is equal to 0, of course, as we would expect, the amount money made would be 200. 250. 250 is the initial amount he put in. So 250 would be the amount made. For example, now let's try T is equal to 1. If T is equal to 1, the amount that's made is 275. And if we go again at T equals 2, we see that this ends up being 302.5, which means after 2 years, we will have already made the $300. So B. Okay, looking at question 18, the equation above expresses the approximate height h in meters of a ball t seconds after it is launched vertically upward from the ground with an initial velocity of 25 meters per second. Jacob wants to run to the tree and back before the ball hits the ground. If he can run at 4.5 meters per second, how far away can he be from the tree and still make it back to his starting position before the ball hits the ground? So because this equation up here tells us the height after a certain time, we're looking for the height of 0 when the ball falls back to the ground. And of course, because it's a parabola, we'll have 2. Hopefully one of those will end up when at t equals 0. So let's take a look at this. We want a height of 0. So we set that equal to the 4.9 t squared plus 25t. And now to solve for this, we can just factor out the t. We're left with negative 4.9 t plus 25, which means that our t can be equal to both 0 or about 5.1 seconds. So knowing that that 5.1 seconds is the time we have before the ball hits the ground again, we want to see how far the tree can be if Jacob can run at 4.5 meters per second. So that means 4.5 meters per second times 5.1 seconds. That is going to give us 22.96 meters. This is the distance that Jacob will be able to run. So if he needs to run to the tree and back, we're looking for half of this. So the distance is going to be 11.5 roughly. Okay. Manipulating quadratic and exponential equations. So let's take a look at 19. The height in meters of a baseball at time t can be modeled by the quadratic function h of t is equal to negative 4.9 t squared plus 19.6 t. Which of the following equivalent expressions displays the time that the baseball stays above the ground as a constant or coefficient? So this one's a little bit tricky because what we're looking for is the time that the baseball stays above the ground as a constant or coefficient. So what does that really mean? What that really means is we need to see it somewhere in the equation. So in our answer, we need to see it labeled somewhere where the ball is going to fall back to the ground. And remember, when the time when the ball falls back to the ground is essentially a 0, a root, or a solution to this equation being equal to 0. So what that means is we can solve for that and just look for that value in the solution. So if we have negative 4.9 t squared plus 19.6 t equals 0, we see that we can factor out a t, so we get negative 4.9 t plus 19.6 is equal to 0. And this means that t is going to be equal to 0 and approximately exactly 4 seconds as well. So looking for the solution that has that, we see that b has this in its solution there because we see that minus 4 right there. And we can see that this is an equivalent expression because if we factor this negative 4.9 t into the t minus 4, we'll actually get this initial expression here. Okay, question 20. The function h represents the revenue in billions of dollars of a company n years after it was founded. And there's h, which of the functions represents the revenue m months after the company was founded. So currently, this n is in years. But then, of course, now we want it to be m months. Of course, we know that 12m should be equal to n, so that can be something we use here as well. However, substituting this in may seem a little bit weird. What we can do is we can say that because there's 12 more months, we only want this to increment by the same rate of change, 1.003, every 12 months. We only want this to occur every 12 units of time, since our units of time is now months, which means that this n can actually be replaced by m over 12. So I know I wrote this here, but note, this is actually going to be m over 12 that we replace the n with, because we wanted to compound every 12 units of time m, as opposed to every 1 unit of time n. So in this case, that means we just substitute the n out with an m over 12. Question 21 says, the function below shows the outstanding money on a loan after t weeks. Which expression best represents the annual interest rate, where 1 year equals 52 weeks? So since here our unit of time is t weeks, but we are looking for the annual interest rate, that means we have t is equal to 52. These are units of time. So we're going to plug that in, and we're left with 2,500 times 1.33 to the 52 over 2, or 26, as our expression. However, we are just looking for the annual interest rate, which means we'll get rid of the principal. So we're left with 1.33 to the 26th. However, this is just the multiplier, and we have to subtract out the principal from here too, which is actually just this one component here. So it means all we have to do is subtract 1 to get rid of the principal and leave just the interest portion. So this is the answer choice B. Okay, Moving on to different forms of a quadratic. A couple of different forms of quadratic, they're used for different things, but let's take a look at the first one, standard form. This one is y equals ax squared plus bx plus c, and this contains the y-intercept if you have it positioned correctly. So this one also allows us to plug it into the quadratic formula and solve for our roots. Next one, the vertex form. Vertex form is useful because it contains coordinates of the vertex, h, k. And this is the minimum or maximum value depending on which way the parabola is flipped. Next is the factored form, so y equals a times x plus b times x plus c, and this allows us to get the solutions. Of course, our solutions being x equals negative b and x equals negative c. Remember the negative one. So, easy way to do that. So let's look at question 22. Which of the following represents the function g where the minimum value of g appears as a constant or coefficient? Like we said before, we're going to want to use the vertex form because it gives us the minimum and maximum. Here, in this case, we're looking for the minimum. So basically means we have a parabola like this, and our vertex here has coordinates h, k, and we want to put it in that form so that we can pull out h, k. So let's first go ahead and expand this. Expanding this gives us x squared minus 2x minus 3. So that's just expanding it and then combining the terms in the middle. Now, what we're going to have to do is we have to go ahead and complete the square so that we end up with an a times x minus h squared component, because that is what we need. So let's look at this component here, and to complete the square, we would need x minus 1 squared, which is going to be equal to, in its entirety, x squared minus 2x plus 1. However, what we have is x squared minus 2x minus 3. So what we need to do to this is actually subtract 4 in order to get our positive 1 that we have here to a negative 3. So we need to subtract 4 from here. So now, this is our expression. And if you expand that out, you'll actually see that this ends up equaling exactly what we have up here. So now, this is our expression, and we can see this is the exact same thing as answer choice D. So we can go ahead and pick answer choice D.